Yo, what is up guys? Welcome back to a brand new video. Before I get to delidding and relidding, I wanted to test some temperature stuff basically. So I'm gonna do some Cinebench runs. So yeah, let me do that. Okay, so you'll be seeing the temps here. So we'll be looking at the CPU package as well as the core temperatures. So I'm gonna do a CPU run. And as soon as this one stops, I'm gonna do one again. 1421 was our score. That is pretty low. I don't know what our score was. Maybe I can see it in the editing. Okay, so that seems to be our end score. My settings for now are 4.9 gigahertz because 5 was just getting too hot. My ring clock, I think, is 4.8. I'm not sure. Bus speed is 100 megahertz. And the volt is, I think, 126. But I'm not too sure. Let me look at that right now. Okay, so apparently I'm running at 1.24 volts. Which is really low. But it is stable as far as I know. I still have to test the stability with Prime 95 or IDA 64. But I am not going to do that in this video. I just want to see the temp differences. Let's just do a CPU Z benchmark with the reference score. And I'm going to stress it and see what my score is. As well as the temperature of the chip. Alright, so it's about 200 points higher. It's still climbing, but it's not going over 80 degrees. And that's because I made the choice to go back to 4.9. But of course I want the maximum performance, so that's why I'm doing this partly. The other reason is to make my PC even more silent. So for regular gaming, you really shouldn't do this. Alright, so these were the tests I wanted to do. The temps go back pretty quick, so it's not my thermal application. The thermal paste I'll be using is from Thermal Grizzly, and it's better because the connectivity is, I think, 11.7 instead of the 4.5 or 5.4 that Icy Diamond gave me. So it should be better thermal paste as well. Now let me delid and relid, and I'll probably be back tomorrow. Also, at the moment it is 22 degrees. So yeah, let's go. We have the relid tool, the 2600K, which I tested the delid tool on already. We have a razor, I don't want to look at that. The delid tool itself, some thermal paste from Hydronaut, Thermal Grizzly, and the liquid metal from Thermal Grizzly as well. Some black silicone, glue, the screws that are necessary, and the tools we'll be needing. Okay, so first let's unscrew the delid tool and put my CPU in there. Trying to show you, and I hope the CPU won't fall out. So I place the screw back until it starts to get tight. And now it's a bit scary, I must say, but you use the force you need to use. And eventually it will pop, and that means you successfully done it, or it will just gently slide off, which was the case for me. You can tell it's starting to slide off from the left side earlier than the right side. Now I'm going to loosen the screw, and as you can see, I can take the IHS off now, and there is the die. Which the thermal application was really bad. This is the IHS. Thermal paste was bad. Okay, so what I'm going to do now is just wipe off the existing thermal paste with some paper towels. You can use rubbing alcohol, which is more effective. It really doesn't matter that much, trust me. As long as it is as clean as you see from me, you're good. The razor, which I hate looking at, which I will be using to remove the silicone from the IHS and the chip itself. I just ordered it from a cheap Chinese site, and as you can see, the razor does its job. Watch out because those things are super sharp. Alright, so after I cleaned the IHS and the chip, I put some red nail polish on the chip because there's 3 connectors, and if the liquid metal goes on 2 or 3 of them, you fry the chip because of shorting. So make sure you do that for extra safety. Alright, so after you clean the chip until it's shiny and removed all silicone. I'm gonna grab the liquid metal. You get 2 cotton sticks. I don't know how you say that, sorry. Which you will use to spread the liquid metal and remove excess liquid metal. This is the needle for the liquid metal. There is instructions with the liquid metal. You can also use this as thermal paste between your heatsink and your CPU itself, but you should not use it with an aluminium heatsink. So if your heatsink is aluminium, except the part where it touches the IHS, you're fine, okay? There's some alcohol wipes with the liquid metal, which I use to clean the IHS and the chip even more, and then I let it dry from the air. So after it's dried up, I'm gonna place some tape around the chip, so if I spill any liquid metal, I can just take off the tape and the liquid metal will come off with it. You don't need to secure it all the way because it will be only harder to take off, so just make sure you get it right at the edges of the chip so you can't spill any liquid metal. Alright, so now for the liquid metal. What I've seen happening is people pushing too hard and it shoots out. I thought, what a dumbass is, but even though I did it so carefully, I still managed to shoot it out as well, so it was a big ball, as you can see. But what you can do, luckily, you can pull back the liquid metal so you suck it back in. Now what you start doing is just rubbing in circles until you get a nice equal spread and you don't think it's too much liquid metal. I still thought this was a bit too much liquid metal, but I adjusted the IHS so I knew around where I should put the liquid metal on the IHS. In the end, I just spread it around the middle until there was a layer of liquid metal on the IHS as well. And you do this so it has better contact directly when you place the IHS back on the CPU. I'm gonna be making that a little bit bigger than the CPU die itself. Alright, so now I'm gonna be taking off the tape with the liquid metal that I spilled onto it. Just take your time with this as well. You don't want to spill it on the board after you've done all this. So what I'm gonna do now is put the silicone glue on the IHS while leaving some gaps for air to come in and out, basically. Make sure not to put a too thick layer on there. This is where I put back the IHS, and apparently the arrow goes on the bottom left, not on the top right. So that's the mistake I made. I figured out which screw has to be after quite some time because it was not symmetrical. So after I tightened the 4 regular screws, the only screw that's left is the big screw that you can tighten by hand to force the IHS down onto the CPU. So I suggest you just tighten it by hand because you don't want to break or bend the actual CPU. And this is how it will look like for the next 24 hours or at least 12 hours. So yeah. Okay, so it's the next morning, it's still in there. I'm gonna try to put it in my computer again, and I'll try to put the cooler back on, which was a pain in the ass because I can't find the right screwdriver. Alright, so I don't know if you'll be able to see this. Oh, that scared me. I could have flipped my whole CPU. Do you see the black glue all around it? Seems pretty solid, seems pretty flat, so I just hope I put on the right amount of liquid metal. So yeah. Okay, so after a lot of struggle, I put the cooler back on. I mean, it doesn't seem super duper sturdy anymore, but I'm just gonna try anyways. I had to even remove my graphics card because this fan was turned the other way around. Got some wounds, but we're good now, I think. I'm gonna put my graphics card back and start the system. Okay, so the moment of truth. Okay, something's going against the fan, which is not good, which I'm gonna fix. Okay, so it's one of the system fans, not CPU fans, because they're quiet. Okay, so I'm gonna turn my computer off and fix the fan noise. Okay, so I'm back with the exact same core voltage and core speed settings, as well as the same version of hardware info and I'm gonna look how it performs. I don't know if I put enough liquid metal on there or not, so yeah, I'm already amazed that it runs, basically. So let me do, I think, 3 tests. Alright, 1406. I think that's lower than our previous score, but our temps maximum was 66 degrees, which is not high at all. Okay, 1407. That's around our score. 67 degrees max. I also stressed the CPU with CPU Z, and our score is still climbing. So it's the same ambient temperature. Maybe my room is a little bit less warm than yesterday, but that shouldn't make that many degrees of difference. Max temp 68 degrees, as I can see. And the fan noise is not the same. Like, because I have a fan curve, right? If I put my fan on 100 fan speed, then I would get even better results with the temperatures. But the reason why I'm not doing that is because this is a real world scenario. And one of the main reasons you'd want to delid a CPU is to get a quieter system. So yeah, it won't go over 68. What I am gonna try now is I'm gonna put it on 5.1 gigahertz with 1.4 volts, even though I can go lower with the voltage. I want to make sure it's stable, plus I want to see how it handles those voltages. So yeah, be right back. Okay, so I'm back. I noticed I didn't close all my stuff in the background with the Cinebench run, so would have been higher, but yeah. I wanted to show you that I'm now at 1.35 volts on 5.1 gigahertz. I'm gonna make sure I have the clock speeds, the temperatures, and the voltage. So let's run it. $14.47, so that's pretty good, because you got to keep in mind I am recording right now, so that is a really heavy task anyways, because it's encoding everything that's happening. I'm not gonna bother changing the core voltage to its minimum yet, because it seems stable for now. This was my highest score with I don't know what setting, because it doesn't really show that, but if I beat this, which I probably will, I will show a screenshot in the edit. Well, I'm gonna do some testing behind the scenes. Alright, so to end this video, my score that I have after the 5.1 gigahertz overclock is 1677. My high score was at 5 gigahertz with 1694. I did that with less faults, so maybe on 5 gigahertz I can even manage to get a higher score than on 5.1, but I'm not gonna bother to do all of that because this is only Cinebench, so it goes deeper than that. Now, as for the temps, I'm gonna run Cinebench again with high priority while recording, okay, keep that in mind, and having hardware info open. So give me a second. Even while recording, I have 1677, which I don't know how, but I have it. So apparently I can go higher. But now let's look at some specs, alright? So I'm at 5.1 gigahertz. As you can see, the lowest is 5.096, aka 5.1 still. On all 6 cores, my ring ratio is 4.9 gigahertz. I can tweak around that one as well, which I'm not going to do now. The maximum temperature for the core max is 81 degrees, which is not hot at all for a 5.1 gigahertz 6-core CPU on 1.4 volts. The lowest core went maximum 76 degrees, and the package itself got to 82 degrees and 139 watts, which normally is, I don't know what this thing is rated for, 100 watts, like normally, without overclock and stuff. So as you can see here, 1.4 volts. So yeah, let me know in the comments if you're gonna delid your CPU and what CPU you have, and leave a like if you enjoyed this video or it helped you, and subscribe if you haven't, it's really appreciated. And peace out, guys. Peace. Yes!
Drive hard. Drive Mustang.